there's going to be some seats here. There's another backpack over there. Could you ask the backpack to free up the space? Excuse me? Just behind you, there's another backpack. Could you remind them? Could you free this space? No, it's already 10:30. Free this space. Someone is going to sit there. If there is an empty space next to you, raise your hand. Could you fill this space there? In principle, we're not allowed to have too many people on the stairs, so I want to minimize that. That's it. We're done. Okay. So I'm going to give it 1 more minute before we start, because I know that people will come in. There's some staircase space here. There's more space on this side if you want. A little bit more. Okay, so welcome to machine learning, applied machine learning, 519, 419. I assume that's why you're here. I know that there's not a lot of room. I think on the stairs this side, there's a bit more room. For people that just come in on the stairs on this side, there's a bit more room. Okay, so I assume that not all of you will be here a month from now, but welcome anyhow. I'm Dan Watts. We're going to talk about what's going to happen in machine learning this semester. Okay, so some things that hopefully you all know. We're meeting Monday and Wednesday. We're going to have office hours. Mine are going to be Monday, Tuesday, which means it's going to start next week. We have 10, maybe 11 TAs. So there's going to be a lot of people for you to ask questions to. I'm going to talk at more length about all these things, but just as a first slide, there's going to be assignments. The class is going to be quite demanding. The assignments are going to take a lot of your time, so be prepared. In addition to 5 programming assignments, there's going to be light weekly quizzes. They're supposed to take 5 or 10 minutes of your time, but basically kind of keep you on your toes, make sure that you are with us. Discussion sessions, midterm, final, projects. So some of you are registered to 519. Project is mandatory for 519. Project is not mandatory for 419, but you can do it. It's only going to help you if you are in 419 and you want to do a project. We're going to talk more about the projects. And there's really no textbook for this class. So you should follow the lectures, hopefully come to lectures. And we're going to, from time to time, also put some notes. All the lecture notes are going to be available. Videos are going to be available. Okay, so as I said, there's going to be a homework 0 that we'll make available in the next few days. Those of you that came through the waiting list already or will come through the waiting list have seen some of it. Basically, the hope is that all of you here are prepared for the class. which means you know some of the math that I'm going to be using, and you're kind of fluent in it, so it will not impact your ability to learn the machine learning. This is the goal of Homework Zero. And I know that on many of your minds, the next question is registration. So let's start with this. How many of you are registered to the class? Okay. So there are more registered than I see here, I think. So as of today, there are 130 registered. I didn't count 130. Who is not registered to the class? Who is not registered and is not on the waiting list? Very few. Okay, so here is what's happening. So the class is not completely full. We left spaces deliberately, but we have a long waiting list. If you come from the other side, you'll have at least a standing space. Okay. So there is a long waiting list. All the people on the waiting list should have received email from me a few days ago. Someone on the waiting list who has not seen an email from me? Good. Oh, that's weird. So you'll have to either come to me or send me email to figure it out. I requested people to renew their membership on the waiting list, and I explained why. Just to say it briefly, a lot of people registered to the class or put their name on the waiting list in April. Large percentage, or at least some percentage of these people are not interested in the class anymore because they are taking other classes, and I want them to not slow us down. There's going to be a process that starts today of getting people off the waiting list into the class. It's going to take 2-3 weeks, so you have to be patient. If you are on the waiting list and you really want to be in the class, just pretend that you are registered to the class. Everything is going to be open. Everything that you need to do, you will be able to do, even if you're not registered, so just wait. If you are in the class and you're considering dropping the class, please do it as soon as possible, because the time for the drop time and the adding time is very short. So I just want to streamline this process. So I know that many of you will drop the class. Please do it quickly if you consider doing it. Other than that, just be patient, behave as if you're in the class. Large fraction of the people on the waiting list will get into the class. I cannot guarantee that all of you will. So I can tell you that the waiting list has over 200 people, but only as of this morning, 99 people renewed their membership. So from my perspective, there are only 99 people on the waiting list. As I said, I cannot guarantee that all of you will get in, but I think a large percentage will. Questions? Yeah.
Is there a way for us to confirm that we can read our spot on the waiting list?
You responded to my email? No, there's no way, because I'm not going to respond to all the 99 email messages. Let's believe in the email system. Given that you got my email, I probably got yours. At least for now. I mean, as I said, wait. If something happens in 2 weeks and you don't hear from us, then verify. Yes?
Are all the questions here available on the class website, or do you have to access Canvas?
Okay, so I'm going to get to it. Everything is going to be available. I mean, videos, lectures, it's going to be open. So as I said, even if you're not registered yet, you'll be able to see it. Okay, so let's start with the class, or what I want to do today. Please go to the web page. The web page is going to be completely up to date in the next few days. If you haven't found it yet, that's your first homework. I'll give you a hint. You can access it, for example, through my webpage. If you don't find my webpage, you should be able to do it. So what do I want to talk about today? And I realize that many of you, unfortunately, cannot sit, so hopefully you have enough stamina, you can stand there. I want to talk a little bit about what is learning. I want to understand a little bit who you are. Yeah, you can come in and sit here. And what the class is about. And we're going to hopefully have a time to play a game. So let me start by who you are. Computer science undergrads. Undergrads that are outside engineering. Oh, few. Graduate students. Okay. Graduate students that are not in CIS. Okay. So we have quite a diverse population. Graduate students that are not in CIS, where are you from?
Linguistics. Bioengineering.
What was that?
Bioengineering. Robotics. Mechanical.
What?
Mechanical engineering.
Okay. Okay, so we have quite a diverse audience, and the reason this is good is because, first of all, hopefully you'll ask good questions because you're coming from different backgrounds, and what I found that the most interesting projects come from people that are outside of computer science because they have some problems in mind that they care about. So this would be nice. So, okay, so let's start. I want to talk a little bit about what is learning. And this is old, but one of my favorite examples to start with. And you can look at it, read it. What is it? Why do I show it? Yeah.
Its meaning will confuse a Google search.
It's what?
Its meaning, because it's sounding, the sound of the words translate the meaning instead of the actual word. It's going to foil many language processing things.
Didn't fool you. It was interesting that you mentioned Google search. In fact, this poem was written before Google search was born, but you're right. So what is it? I see some of you making, smiling. Why are you smiling? Nothing is wrong. Maybe nothing is spelled right. Yeah, so it sounds okay. It's full of spelling mistakes. Now, no spelling corrector today, and there's been some progress in this area, will identify even one of these spelling mistakes. But it's very easy for you. So why is it so easy, and what should we do in order to do it? Can you write a program that takes this as input and identifies all the mistakes? Why is it so easy for you? Yeah.
Conventional knowledge.
What does that mean?
So we have a library now. All the common phrases and you will print these closest.
Okay, so I'm not sure exactly how you do it. Maybe you do, but it's completely clear that you've read a lot of text in your life, and somehow you've generated some representations and the ability to figure out that something is wrong here. And it's also clear that if you try to write any conventional program that will correct this, it will fail miserably. So this is one example where machine learning comes into play. And by machine learning here, I mean some program that read a lot of text also and manages to represent things in such a way that will allow it to identify that something is wrong here. We're not there yet, so there's some challenges for you after you graduate from this class. But really, machine learning is everywhere today. So we can look at a picture today, and we can have programs that recognize who these people are. And I assume you know, so I'm not going to quiz you. But we're going to come back to this picture a little bit later. Spam filtering. Here is an example of a message that mail thinks belongs in the junk folder. Here is a translation program. Again, a machine learning program. I don't know if it's correct or not. Some of you are smiling, which means it's not. But translation is also not perfect. You go to Amazon, you buy things. This is, you go through the recommendation system, a machine learning-based program. You also suffer from the ads, machine learning-based programs. A lot of the things that you do is based on machine learning today. So classifier were trained to do it. So if you think about specifically spam filter, which is a very simple program conceptually, it's what we call a binary classification task. Given email, you want to assign to it one of two labels. Is it spam or not? Doing this, or the operation of classification requires that we have a model or a classifier to determine which way to label each of the items. And basically what we're going to do in this class is we'll study how to develop algorithms that do that learn from data to assign one of these labels. Now, it's not always binary. Here is an email message that is about this class, and it's a picture from my iPhone. My iPhone thinks that this message should go to my CIS 519 Fall 18 folder. I have a lot of folders. So in this case, the classification problem is a multi-class classification. Given the email message, figure out which of my folders it belongs in. This is a very hard problem. iPhone is doing kind of like 50% correct. Still saves a lot of time to me. But hopefully, one of you in the project will solve this problem once and for all, and I'll be able to get 99% correct on filing my email. Not an easy task. So what is the problem? Conceptually, it's a very, very simple problem. Given a document and some label, red in this case, and another document with another label, blue in this case, and another document, green, another one that is labeled blue, and so on, a collection of documents that are labeled some way. Once I'm looking at all these training examples, comes a new document, and it does not have a label, and my job is to assign a label to it. That's it. That's what the class is about, basically. And it turns out that it's not so simple in many cases, but it's a very, very general formulation. So the documents could be many things. It could just be documents, and then the set of label could be, what is the topic of this document? Is it about politics, about sports, about finance? It could be a collection of sentences, and you want to know whether the sentiment expressed in this sentence is positive or negative. It could be a collection of phrases, and you want to know what is the semantic type of this phrase. Is it the name of a person? Is it the name of a location? Is it the name of an organization? It could be a bunch of images, and you want to identify other cats or dogs or snakes in this. Or it could be medical records, and you want to be able to determine, should this patient be admitted, will this patient be admitted again soon or not? Many applications, all of them have the same formulation. And that's basically going to be the core problem that we're going to look at in this class. Now, it's not as simple. Today, we can easily develop models that will recognize these people. But when you look at this image, you know a lot more than what the names of these people are. What else do you know? You know who they are, how they are feeling, why they're smiling. What else?
All our presidential candidates.
All are presidential candidates. Yes, that's true. Yes.
Political party they belong to.
Okay, that's a lot of background knowledge, but just from the image, even without that, that's because you know the name. Just from the image, what else do you know?
Age.
You know something about age, gender, skin color, ethnicity, even more, I think. Okay, you know that they're sitting on a stage. In fact, you know more. You know that there are probably other people there. Right? I mean, if you were to bet on it, I think 99% of you would say yes, there are other people around it because of the way they're sitting. You know that they are probably affluent, the way they're dressed. You know a lot of things. Now, I actually started with names of people, name recognition. Train a classifier for recognizing their faces. But notice that you know a lot more things about them. Are you going to train a classifier for each one of these? How are you going to do it? So I want to bring this up already in the first 20 minutes of the class. There's a lot of limitations to machine learning today. Here is one. Basically, almost everything people are concerned with and spending too much time and energy and CPU, GPU, TPU time on is on the simple classification problem. There's a lot more to it that we need to learn, and it's not completely clear how. Can we do everything together? What else do we need to bring in? I mean, all your comments suggested that we need to bring some background knowledge into the picture. There's a lot of interesting things happening. Here's another interesting example. This is a short story. This is the type of short story that those of you that grew up in the US did in your second grade reading comprehension test. You got this story, and then you got 4 questions. I changed the question a little bit. I made them statement rather than questions. And then you answer it. And once you can read, you can answer these questions. But you can think about what does it take to write a program that will be able to answer this question. And specifically, I'm going to ask you some very direct question about this paragraph. There is 2 names here, Christopher Robin and Chris. Is this the same person? Who says yes? Who says no? Okay, I'll give you a few more seconds. Who says yes now? Who says no? Most of you don't say anything, which is unacceptable, right? So you have the right to vote, you should vote. Who says yes? Okay, who says no? We're still reading, right? So is it the same person or not? Okay, so by majority it's yes. And anyone wants to say no and explain it? What about this person here? You can see it. Can you see this? What about Mr. Robin? Okay. So we have Christopher Robin, we have Chris, and we have Mr. Robin. Are they all the same person? One is their father. And it takes a lot of time and it takes a lot of thinking to just realize something like this. And this is just one of the things that you have to do if you want to answer these questions. If you think about it, there's a lot of other pronouns here. You have to make a decision with respect to each one of them. Who is this referring to? You can think about it as another classification problem of the type we discussed before. You can maybe think about it differently. These are all hard problems, and you have to solve many, many other problems. You have to understand numbers. There's a date there, June 89. There's a year, 1925. You have to know what this means. You have to understand something about what am I going to do with those if I want to answer some questions. So there's a lot of questions that you have to address of different kinds just in order to understand a question and answer it. And many other relations in the sentence. So really, it's not directly a learning problem or a classification problem. I call it an inference problem. But where is the learning? Clearly, there's a lot of learning that supports being able to answer these questions. Where is this happening? When is this happening? Something, again, to think about. Here's another example. What do you see here? You can just say. Okay, I hear shoes, animals, vegetables, cars. What do you mean? The whole thing could be a kid's wallpaper. But already in the answers, the specific answers that you gave very different types of answers. So what do you mean when you say vegetables? It's a class of things, right? There are green peppers, onions, maybe other things here. So basically, you did not give me a specific item, but rather you gave a class of items. You can also notice here that the sizes are completely wrong here, right? So the cars are sometimes smaller than the shoes. You may also notice, if you look very carefully, that some of the shoes are more similar to cars than to other shoes. If you look at it at the pixel level, it doesn't bother you at all. So one of the questions that we can ask here is the first question, the vegetable thing, which is clustering. So you actually clustered these items into some classes based on some notion that isn't listed here, but rather based on something that you brought from home. And the question is, how do we do it? And how are we not affected by a lot of things that in real world are important? Size, colors, orientation, many, many other things. So this will be a clustering problem. And toward the end of the class, we're going to play also with these kind of things. Okay, so now that I've given you a few examples, what is learning? So clearly learning as a word, if you look at the dictionary, is something that is at the core of cognition, high-level cognition, supporting what I call here knowledge-intensive inferences of the type that you have to do when you answer questions relative to a short story. But also, and this is why all of you are here today, I think, and this is what makes machine learning so popular today, basically building adaptive intelligent systems, and in general, dealing with messy data, real-world data. So there are many, many purposes for machine learning or for learning in general, and those of you that have already played in applications or have applications that you care about know that you can think about it as a way to acquire knowledge. You can think about it as a way to integrate many knowledge sources in order to support behavior, decision-making, and so on, and as a way for adaptation. So you can think about what is learning, or what is the core? How do we define what that is? And in fact, I'm not going to ask you to try to define it now, because we're going to get about 200-something definitions. I'm going to give you a definition that Herbert Simon, actually an economics Nobel laureate, but also one of the people that started AI, gave. Learning denotes changes in the system that are adaptive in the sense that they enable the system to do the task or tasks drawn from the same population more efficiently and more effectively the next time. That's his definition. And if you think about it, he said there's a lot of important things that are being said here. Drawn from the same population is really important. Because if I give you some examples and then quiz you on examples that are completely different, drawn from a different population, and I'm waving my hand here. I don't know what it means, population. We haven't defined anything yet. But intuitively, at least, you would feel that it's going to be unfair, and maybe you will not be able to make the right decision. So that's really an important thing. But I'm going to take it one step further and talk about an even more important and sort of way to think about it. Really, I want to think about it as the ability to perform tasks in situations which has never been encountered before. It's still from the same population, but it's never been encountered before. So if you think about it, you do this all the time. Whenever you look around this room, you see something that you've never seen before at a low pixel level. Whenever you hear me behind my fine accent, you've never heard this before, you get it. And if you don't, you'll get used to it. We are very, very good at performing tasks in situations which we've never been encountered before. So really, and that's really the core of what we care about in machine learning. Learning, to me, is generalization. So if you've already seen examples, of course, you can do well on them. The key is how to deal with examples that you've never seen before. So when I showed you this email before, and my iPhone decided that it belongs in a specific folder, this is a completely different item. It has never seen this item exactly. But it might have seen emails from the same sender, maybe with the same subject. But some things in this email are different than it has seen before. Otherwise, it won't be interesting. And it needs to make a decision. Maybe what's important today is not the sender nor the subject, but something else in the message. And you have to take this into account when you decide which folder to put it in. So really, the important thing is to classify items that we've never seen before. And this view of learning as generalization is something that is going to happen in all domains that you care about, from various classification tasks to planning and acting. You know, if you think about playing games using machine learning, driving a car, we know that it's becoming extremely popular to think about this. And for those of you that follow the industry, they also know that the industry is kind of stuck today. And maybe that's too strong a word, but it's not far from truth, because there are some things that we don't know how to do well when they are new. Skills or common sense reasoning, all these are really important, and they highlight the fact that really what we care about is the ability to perform tasks in situations that we've never encountered before. Now, one thing that is going to come a lot in this class is that this ability to generalize doesn't only depend on the algorithm you use. It's even more important to think about the representation. What is the representation of the input that you care about? And this is going to be something that we're going to talk a lot about in the class. And if you don't know what I mean now, it will be clear. Okay, so I want to start now with giving you an example. I think we'll have time to do it. So I have enough for, I think, every two of you to share this. So just send this up from this side, and you can send it from this side. And every two of you, or even three, and you can send it in on the middle. So this is, so you're going to see some paragraph that writes something and explains it. I'm going to say it now. And then you're going to see a list of people. And there's a question here. Don't answer the question yet. Don't tell me what's behind this, even if you know the answer. The background story is this. This is taken from a puzzle that was given in the machine learning conference in 1994. Believe it or not, there was machine learning in 1994. I was a PhD student there, and you'll see my name there. So the organizer of the conference gave a list, all the participants, I think, in that conference. Some of them had a plus next to their name. So when you register to the conference, you got a badge. That's why it's called the badges game. And the badge had your name, maybe a few other details, affiliation, and so on, and a plus or a minus. And the goal of the participants was to figure out, why do you have a plus, why do you have a minus? What is the rule behind this classification? Or if you want, given a new name that did not have a plus or a minus, classify them as positive or negative. So everyone has it? As I said, don't solve it yet. We're going to discuss it toward the end today. So this is a machine learning puzzle, and I want to be able to talk about it today once we are done with other things. But this will be a good example for us to think about generalization, representation, algorithms, and some of the principles that are important to think about and sometimes get lost if you only think about algorithms. But let's continue. So I assume that you can multitask, you can listen to me and answer and ask questions while we are talking about. So we already saw this picture before. And I told you that machine learning has some limitations. So let's assume I took this as one of the examples in training for face recognition. I'm not sure if it's going to work on this. So here's an example for you if you want to think about same population. Right? So I train on these kind of images. I want to test, or I want it to perform also on these kind of images. Is it going to work? Something for you to think about as you try to make progress in machine learning. Or here's another example. It's a little bit more involved. It's not directly a classification problem. In New York State, the longest period of daylight occurs during the month of June. Everyone agrees it's June? If you have a program that knows how to answer it, may not be a simple classification program, but hopefully something that we should be able to do today. This program answers this question for the right reason. It should be able to answer also when I replace New York State with this? What's the answer now? Now it's December, but it's the same question. Hopefully you agree with me that it's the same question. Not so easy. Is it the same population? Well, it depends on the representation. And it's not so easy to come up with a representation that will yield these two questions the same. You know, you agreed with me that it's the same question, but agreeing on that really assumes some representation, or at least some principles of representation. Okay, so we already agree here that machine learning is important. That's why all of you are here. So I'm not going to give you all these quotes. I mean, this is from 2 years ago, and it's already passé because everyone agrees. So, but really, why do we want to study machine learning? I think there are many reasons. All of you have your own reasons. One reason today is because it's very, very hot. And half of you believe that once you know machine learning, your future is all set. But basically, the time is right. And the time is right not only because of the job market, it's mostly because we have initial algorithms and theory in place. We have growing amounts of online data. And during the class, you will learn to make a distinction between a lot of data and a lot of supervised data or annotated data, not the same thing. We have computational power. In fact, we have probably too much computational powers, and we are abusing it as a community. And also necessity. I mean, there's many things we want to do, many communities want to do, and we realize that we cannot do it by conventional programming. And almost all the examples that I've given you earlier are such examples. You cannot solve it with conventional programming. You have to involve some sort of machine learning. So really learning is the future, and I think that many people agree that learning techniques will be the basis for every application that involves connection to the real world, to the messy data in the real world. And there's a lot of exciting development in this. But at the same time, there are many, many unresolved issues. I already have given you some examples for that. Think about it. So there are many things we don't know. And this is one reason why this class is not about deep neural networks. I assume many of you heard too much about deep neural networks, but this is just one algorithm or one class of algorithms. We're going to talk about it, but we're not going to talk only about it. So the issue is that because machine learning is so hot, very, very active fields, way too many papers are being written, both scientific papers and in the various levels of the media. It raises the question of what to teach. Now, what I'm going to try to teach is the fundamental paradigms in machine learning, things that are going to stay once this algorithm or that algorithm are going to disappear. Most of what's happening today in machine learning will disappear. There's just no question about it. Very few things are going to stay. And I'm going to make an effort to teach you the important algorithmic ideas, the important principles, and also try to think about modeling. All these are going to stay. And at the same time, highlight what we don't know. I mean, what is the role of your generation to understand and resolve and make progress on. And I'm going to give you one example to bring this home. So the US Open started this week. Anyone saw any highlights? Oh, just a few of you. What are you doing with your time? Well, so there are over 700 matches in about 2 weeks' time. And a lot of people are trying to do many things, but among them is trying to generate highlights that range between, I don't know, 30 seconds to 5 minutes. If you think about it, what is a highlight video? It's very difficult to define. So a machine learning problem, right? Let's write a program that takes 5 hours long match and generates, 30 seconds, 3 minutes, 5 minutes highlight. Not so easy. Any ideas?
Audience reactions.
Perfect. So you read the rest of my slide, but that's actually where I'm getting. So just by watching the video of the game, it's going to be very, very difficult to do. And it's going to take a lot of manpower. But if you just walk outside the stadium, you're not watching the game, you'll be able to tell this is something that deserves to be in the highlight or not. And basically, acoustics is a great signal. Crowd noises in general, gasps, cheers, and so on. Also, gestures and reactions of players, again, without looking and understanding the game at all. Now, even that isn't trivial, because Federer is going to draw more gasps and cheers than some other player that is ranked, 103 in the world. You have to be able to calibrate, you have to be able to do a lot of things, but the reason I'm mentioning it is exactly your response here, that the signal, the supervision signal, is this part of my highlight or not, may not be direct supervision, maybe some indirect signal, acoustics, gestures, other things, and we often want to supervise things with what I like to think about as incidental signals, not things that are directly related because they give you a lot of hints. And we do this all the time. Machine learning doesn't know how to do it and definitely doesn't know how to do it systematically. So here is, again, something for you to think about. Okay, so I think you know something about what we're going to do, and let's be a little bit more formal. So what are we going to do in this class? So we're going to start with an introduction. We already started with an introduction. We're going to complete it, hopefully, next week. And we're going to start with one detailed example of linear classifiers. And we'll already introduce one of the key, or the key algorithmic idea that will carry us throughout the class, all the way from next Wednesday to the beginning of the second half of the class, including deep neural networks. So the algorithmic ideas are common. In fact, very old algorithmic ideas. If you want, go back 200 years to Newton. That's what we do in machine learning today. It's called gradient descent. We're going to talk about two basic paradigms, discriminative learning and generative or probabilistic learning. We're going to talk about multiple learning protocols. The key one is going to be supervised learning because that's what we know and that's the most important one, but we're going to talk a little bit about unsupervised learning and semi-supervised learning. And we're going to talk about many algorithms, from gradient descent that is going to go with us in the course of many algorithms, decision trees. We talk about linear algorithms for linear representations, algorithms for neural networks, talk about algorithms for probabilistic representations, and then talk about semi-supervised EM, expectation maximization algorithm, clustering. Hopefully we'll get to dimensionality reduction, and maybe a few other issues like fairness and ethics that are important in machine learning today. We'll see how much time we have. Of course, we're going to talk about modeling throughout, and evaluation, methodologies, and so on, things that are going to be important. Okay, so that's the syllabus. We're going to mention it again. It's going to be clear on the website. We already talked about this. So what have you learned so far today? So two things hopefully you knew even before today is what do you need to know So my expectations are that you have had exposure to some theory of computation, you've seen algorithms, you've seen probability theory, at least to some extent, and you've seen linear algebra. Now, I don't expect that you are an expert in linear algebra, but we're going to use a lot of notation from linear algebra, not something very sophisticated, but at least to the extent that you know some of these notation, you're fluent in it, it doesn't bother you, you can read a slide that has math on it, that these are my expectations. And all the programming in the class is going to be in Python, so I'm expecting that all of you have experience in Python. We're going to give a tutorial in Python in the class in about 10 days, and there's going to be 1 or 2 tutorials in the recitations, but if you haven't done anything, you should take the class next time after you prepare yourself. So we're going, as I said, we're going to have homework 0. I expect you all to do it. We're not going to grade it, but we're going to give solutions. Again, I don't expect that you sit down and you immediately solve everything, but if you are not comfortable with at least 2/3 of this, after a couple of hours of looking at it and playing with it, then it means that you need to take the prerequisites and come back next time. So basically, you have to be honest with yourself. I know that you want to take the class, but I don't want you to suffer in the class. I want this experience to be enjoyable to you, to me, and to the TAs. And I know for sure that if you're not prepared, you're not going to enjoy it. So please, be honest. Okay. Hopefully you've already realized from the last hour or less that I really would like you to participate. I want you to respond to my questions, and I want you to ask questions. It's really important that you respond to my questions and my comments and say something, because that's the only way I have to understand how you think about things, what you know, what you don't know, what misconceptions are there. It's really feedback to me, as well as feedback to all of you. So please do it. Asking questions is really important. In fact, and this is a fact, whenever you have a question, rest assured that at least half the students in the class have about the same question. So please ask it. You're doing a favor to your friends, and you're helping me to teach the class better. So please don't be shy. Now, before we get to this, all of you know that the phenomenon of, after class, there's a long line next to this podium here of people that want to ask questions. And again, I guarantee that with 1 out of 20 exception, the same question that you have, many, many other people have. So please ask it in class, because people want to know. And even if they didn't have exactly the same question, it will be interesting to them. So this could be a question about the class. This could be any question about, procedures, registration, anything. People have the same question, so ask it. Yes?
Is there a recitation for this class?
There will be 2 recitations a week.
Is it scheduled?
Not scheduled yet. It's going to be in the late afternoon hours. Will be announced. Yeah.
So can you please elaborate on what you mean by incidental signals?
Yes, I will. So give me a second. Let's see. Yes.
Where is homework 0 posted? Is that
It will be on the website. So the website is not completely ready, but since we have a week until the next class, it will be ready before the end of this week. And we'll post it on Piazza.
you mentioned you could find the website through your website page? Is there anything
That's one way. You can go through the department, but it's harder. Just Google my name and you'll find it. and that's a challenge for you. You'll figure out how to navigate from there to the class webpage. Yes.
I missed what you said in the beginning, but if we're still on the wait list, what do we do?
Okay, so let's go back to registration because I know that's important to you. What I said at the beginning is that we left slots open in the class. At this point, there are just about 20 open slots. There are about 99 effective names on the waiting list. And by 99, I mean there are actually 200s, but only 99 of you responded to my question, do you want to still be on the waiting list? So I count only you. If you are on the waiting list, be patient, come to class as if you are registered to the class. With high probability, most of you will get in. So just be patient. It will take a few weeks. If you are registered to the class and you are considering dropping it, please do it quickly because people are waiting. That's the best I can say today.
So if we have not received an email from you, we will just shoot you an email?
If you have not received email from me and you are on the waiting list, when did you join the waiting list? Okay. So people that joined after Saturday did not receive email from me, send me email. All the others should have, if you were on the waiting list before Saturday, you should have received email from me, and I know that many of you have because I received responses. But basically what's going to be in this email is what I just said. Other questions on that? Yes?
What is the priority for getting off the waiting list? Like, is it based on year or based on first come, first served?
So that's actually a complex rule. It's a set of rules, nothing learned here. So the department or the college has some priorities. And on the waiting list, the way I see it, people come with 1, 2, 3, 4, 5 next to their name. So it's sorted by this. It's sorted by the day you put your name on the waiting list. And I'm also looking at your responses to the quiz or the questions that you were asked. And that's it. So people that are 1 are going to be in before people that are 5, unless you give me a very good reason that you should be higher priority than the department thought you were. I have no idea how they decided on these numbers. I think it has to do with your majors, the year you're at, and whether it's your last semester or not, or stuff like that. But I'm willing to entertain questions on that. But don't do it now. Let's wait a week. I think within the next week, some percentage of you will drop and some percentage of you will get in. So we'll be in a slightly more stable situation next Wednesday. Yeah.
Is recitation mandatory?
No. We cannot make mandatory additional hours, but we will let you know what we are discussing in the recitations, and we'll recommend that you'll come. Think about them as extended office hours. Yes?
Sorry to keep talking about the recitations, but if we are making our class schedule now, around what time are we thinking? It's still pretty open.
Okay, so that also depends on the time of the TA, so I cannot commit to anything, but we're going to try to make it in the late afternoon. It's not going to be on the same class day, so if one of them is on Wednesday, the second one is going to be on Tuesday or Thursday, and it's not going to be in exactly the same time. That's what I can tell you now. Yes?
So we didn't know if they're off the waiting list by September 29th. Is that the last day?
In fact, I cannot guarantee that. Sorry, it's just an issue of, people make their decisions, their own decisions on their own time. So what could happen is that if you really want to stay in the class, you'll have to wait a little bit longer and then petition. There is a process of petition to be on the class, so it's a little bit, requires a little bit of paperwork, not a really big deal, but it happens. Every year it happens. So, there was another question, yeah. The recitation at this point are not recorded. The classes are recorded. I hope. We'll see. Hi. Other questions? Okay, so let me say one other thing. The class is called Applied Machine Learning. And really there are two important pieces of information here. Applied in the sense that we're going to ask you to apply ideas from the class and from outside the class, because not everything is going to be covered in the class. Some of it is going to be covered in the long homework assignment that you'll get. But the hope is that we will allow you to play with and understand issues in applied machine learning. Questions that are important when you go out and try to solve a problem. It's machine learning, and the machine learning part is going to be covered mostly in the classes, in the quizzes, in the exams. So expect to see a difference between the quizzes and the homework assignments, except to see differences between what you see in the exams and what you see in the homework assignment. So don't be surprised when you see it. Of course, we'll give you examples, but I just want to prepare you that you can think about it as kind of two parallel paths. Hopefully we'll meet quite a few in different places, but it's not going to be the same. What you see in class and what you see in the homework assignment is going to be quite different. Okay, so let me move to policies. I still want to attend to the puzzle a little bit. Okay, cheating. It's a large class. The policy is simple. So we really take it very seriously. I hope that you are here for a reason. You really want to understand machine learning. So take it seriously. I'm going to take you seriously, and expect that you are here to learn, and you're here to kind of work. And I already said at the beginning, I want to say it again, it's going to be hard. You're going to spend a lot of time on each homework assignment. It's going to vary depending on how well prepared you are for the class. But I know that some of you will spend 15, maybe 20 hours on a homework assignment. So I'm still expecting that you're here to learn and you want to spend the time. So respect it. So, okay, so the homework, as I said, we encourage collaboration. So definitely find other people to talk to, work with, discuss things with, come to the TA office hours, come to my office hours, ask questions. But you have to write your own solution and your own code. So this is where learning happens. When you step aside from your group, you write things down after you kind of figured out things in principle with your friends. It's essential that you do this. Okay, so we have a late policy that is also simple. We're going to give you 4 days of credit. That's it. Use it any way you want. It's a lot of time because there are only 5 homework assignments. Please don't use it at the beginning and then come at the end and say, I ran out of time. Budget your time, think about it, because there are always some, exams, weddings, interviews, what have you, and you figure out at the end that you need more time. Please budget it, but it's a simple policy. We're going to track when the deadline is, when you submit it, and that's it. So you don't have to ask us. Okay, grading. One second. So possibly it's going to be separate for graduate and undergrads. I say this every year, and the class is large enough that I kind of know how things are going to go. But it's definitely going to be different for 519 and 419. Here is how it's going to go. Homework is 40%. Final is 35%. Midterm is 20%. Quizzes are 5%, which means it's going to be about half a point for a quiz. I do recommend that you do the quizzes. Here and there's going to be some extra credit to the problem set. If you do a project, it's going to count 20%. So 519 have to scale this. The first row worth only 80%, and the project is 20%, which means that the project is a significant part of the class. It's 20% of your grade. We're going to talk about it more, but it's going to hopefully be interesting, and we'll spend some time into it. Questions? You will.
With the credit of 4 days, do you choose what assignments they are applied to, or?
You do it yourself. Four is throughout the semester, 4 days throughout the semester. So you decide whether you want to take any, you want to be late or not. But if you are late, we're going to count how late you are, sum it to 4 days, and from that point, if you exceeded it, you don't have any late time.
So if you're late 5 times, it'll only apply to the first 4 assignments. You can't make it apply to
No, you cannot. If you use your 4 by the 4th assignment, you don't have any minute of late time for the 5th.
You can use it by hours, right?
You can use it by hours. Yeah. 96 hours if you want. So that will be clear. So I don't want to get into it. It will be completely clear how you submit when we get to it. Okay, so as I said, the class website is not completely up to date now. There's going to be a detailed schedule there. And there's going to be some pointers on the notes column, and you'll be able to see it. Okay, so if there are no more questions, the badges game. So let's see if I can show it here. So I don't want answers, but assuming that some of you managed to look at it, I want to know if anyone, okay, now that's another challenge that we have. Okay. Let's see if I can show it. I want to know if someone thinks that they have the answer. Don't tell me the answer, just tell me if you think that you have it. You have the answer. Why do you think that you have the answer? Don't give me the answer, just tell me why you think it's the answer.
I created a hypothesis and I tested it on some new things and it turned out to be.
On some things from the list.
I can't find a case that disproves my answer.
Okay, so basically it's the same answer. It's consistent with the data. That's what you're saying. Okay, that's good. Other people that think they know the answer. Yes?
So the training error is 0.
The training error is 0. That's the same answer, right? You're consistent with the data. No, it's good. It's good because we already got 3 ways to say the same thing, which is good. But I just want to make sure that we know that it says the same thing. You develop the hypothesis based on some of the data, and you find that it's consistent with the rest of the data. I'm still trying to bring it so that you can also see it on the screen. It seems like it's not so simple. Okay, let me not fight with it now. Any other answers? The reason I'm asking this is, can you give me this page just for a second? Because I also have a hypothesis that is consistent, just like yours. Here it is. This is a hypothesis, right? And it's consistent with the data completely. For every name in the data, I know whether it's plus or minus. I'm going to use this as my hypothesis. Why is yours better than mine? This one. It's the list of all names here next with pluses and minuses next to them. It's a hypothesis, right? It's a function from names to plus or minuses. It's behaving exactly the way yours does. Why is yours better than mine? Okay, we're getting there. There's someone in the back that wants to say something.
Generalizable at all?
Doesn't generalize. You mean, I don't know whether you are a plus or a minus.
Yeah.
Okay, good argument, right? Someone else, yes?
Yours isn't defined on most names.
I cannot evaluate my function on your names. I can do it on mine because it's here. Yes?
Yours can deal with the new names. Can deal with the new names.
Cannot deal with new names, right? So that's actually one good argument for why yours is better. I want another argument of why you are convinced. Why did you stop looking? I mean, you looked at it, you thought, after a few seconds or minutes, you said, oh, I know, and you stopped looking. Why did you stop looking? Yeah.
Because I think it's simpler than having a case to something.
Okay, now I like this vocabulary choice. It's simpler. What does it mean it's simpler? You have a very compact function, and you believe that this is the right solution because it's so simple. Is that a convincing argument? Simple explanation, you know there are what, many names here? 200 some, I can't remember now. It's written here, 210 positive and 84 negative. A lot of names, and you have a very short explanation. That's convincing, no? We'll see that actually this should be mathematically convincing. It's going to be called Occam's razors, and we're going to prove that if you have a simple explanation, it's better than not so simple explanations. So I have a few other questions here. So one is, I gave you this list as the input. The people in the conference did not get this list. What they got is badges. Every person had a badge with a plus or minus. Which problem was harder, yours or theirs? Why is theirs harder? Say it again. They have to go out and find the data. They saw one by one. True, yes. Yeah, but that's the same argument. They didn't see all the training data like you. One more argument, yeah? Okay, just 1 second. So one here says that you have to memorize it. You see one by one, you have to write it down. Here I put everything on one piece of paper. What did you say at the back?
I said the scope is smaller because we know the information to solve the problem is in the name, whereas they didn't necessarily know that.
Right.
Because it's just a person with a tag.
So when you look at a badge, what does the plus or minus depend on? Shoe size? Height? Country of origin? I don't know. Color of a shirt? You don't know. Here, I already told you, it's a function of the name. How would you solve it? So that's a very, very important distinction that made it much, much easier for you than to them, because I basically narrowed down the set of features this could depend on. We're going to see this word a lot. in this class. If you were to write a program that solves this, what would you do? Yes.
Both X and Y. So the output is sort of plus or minus and
Yeah. Okay, and? What would you do? What would be kind of your first thought about how to write this function? Yes.
You would need probably some way to like vectorize like the names to get some like potentially relevant quantities, like like the letters in the name or like the syllables.
Okay, excellent. So you have to think about what this might depend on: length of the name, what characters appear in it, other things that this could depend on. Vowels versus no. I don't know what vowels are. It's here in the input? Okay, remember that. What else could this depend on? Middle name or not middle name? Yes? What do you mean by alphabetic order?
if you know the order of the alphabet or not.
But how does the
Maybe plus is if the first name comes before the last name.
Okay, so basically function of the characters, function of the length of the names, function of properties of the characters, and so on. A lot of things that this could depend on. Okay, so now that we're out of time, you were first. What's your solution?
If the second alphabet is a vowel, it's plus, it's a consonant, it's minus.
Everyone agrees?
Yep.
Okay, so think about it a little bit more. Think about how this is a machine learning problem and how would you solve it. Not easy, but you're going to do it in one of the problem sets. And I'll see you next week.
Maybe I think 2 days ago, I got an email from you, but I'm registered for the class.
Oh, yeah, I saw your email. I haven't checked it yet. So you're both on the waiting list or in the class?
No, I'm just on the wait.
No.
I'm just registered for the class.
But you got my email that I sent to the waiting list?
Yeah.
So it means that you are also on the waiting list. I'll check and clear you from the waiting list.
Okay.
It's good. That's one more spot. Yeah.
Okay.
I remember that I saw your email, but I haven't had a chance to check it. Yeah.
And just a quick question. So we don't have a quiz this week, right?
No, we haven't started yet. Hi.
For the waitlist 2 days back, I didn't get your mail, but
Yeah.
I got to know from my friend that you have sent mails for every.
Yeah. So I talked about it.
So I replied to you yesterday night. I sent that string inside thing.
And did I respond to you?
I got a mail from you that you're a little busy right now. You'll be responding to the mail a little later.
Okay, so basically if you're in, so I sent it on Saturday. If you joined the waiting list after Saturday, you didn't get it. But I understand that you want to be in the class. So that's it. So the reason I sent this email is because I wanted to make sure that people want to be in the class. About half the people on the waiting list actually don't want to be in the class anymore, so you do.
I want to join the class, so I'm interested in.
Yeah. So I got your email. You're on my list now.
Okay, fine.
Don't worry. Okay. Yeah.
From statistics department. I'm a PhD student, but I'm ranking the last. I'm ranked 5. I don't know why, because maybe it's because I'm from Wharton and they thought we are a business school. Actually, stats department actually do a lot of deep learning and machine learning stuff.
Yeah.
So I don't know what can I do to maybe to help that I get into this class.
Actually, so as I said, I don't know how they assign the numbers.
Yes.
It's a sophisticated machine learning program. But wait a week and let me know again. I mean, so things are going to be a little bit clearer, I think, in a week. I mean, I did have people from Wharton and statistics before in the class, so there's no reason you will not get in, but let's wait and see.
Okay, thank you.
So you're a PhD student in
Yes.
statistics? Okay.
Yes, I'm also very interested in learning some this kind of stuff.
Okay, okay. So
Thank you.
it's good that you're here.
Dr. Raff, I'm a DTN. So I registered for this course last semester and I got in as 419. And my advisor told me like if I wanted to switch into the 519 version.
So you see, this is a good question that you should have asked
Okay.
in the
sorry.
class, because there are at least 20 people that care about this. Don't drop the class.
Okay.
We're going to switch you, because if you drop, you lose your spot, and then you're going to fight on the spot again. So you can wait, it's not urgent. The right way is to ask Nick from the academic office to switch you.
Okay. Gotcha.
So you can send me email. You don't have to do it today because there's time, but we can switch it.
Okay. Sure. Thank you.
Sure.
So can you please elaborate on the incidental signals part?
Yeah. So I didn't get to it. Let's not do it now, because I'm sure there's a lot of policy issues. But don't forget, because it's very interesting, and it's very interesting to me. I can send you a pointer to papers that discuss this issue.
I'm Hao Yu from China. I'm working with you with the independent study.
Okay.
So I wanted to ask, you mentioned several EMLP 2019 papers I need to look at. I don't know how to get access to them.
Oh, so I did not send you pointers. We are meeting tomorrow, right?
Yeah.
So let's talk tomorrow.
Okay.
Yeah.
Thanks.
Yeah, come on. Just want to get organized, because maybe someone will teach here at noon. I don't know. Yeah.
So I'm a PhD student in chemistry, and I'm actually in my 6th year, so I'm in my dissertation year. And our courses are we can't pick them ourselves. They have to go through our coordinator. So I asked her, and she said since I'm in my last year, I might only be able to sign up for this course as an audit and not take it for credit.
I see.
Also because I already fulfilled all my course requirements for my
Okay.
PhD.
Also, you don't need more classes.
Yeah, but I'm doing my research in computational chemistry. So and I'm interested in learning this.
You can audit the class, from my perspective. So I don't know if you need any approval or anything, or you can just come.
So for auditing, I think I can just tell the department and they can.
Okay.
But since you said there's a waiting list, I don't know if.
For the audit, it doesn't matter.
It doesn't
you can just
matter.
come.
Okay. But I still have to register for the audit.
I don't think so, unless your department wants you to. From my perspective, you can just sit. If there is a place to sit, you can just sit. And the only thing is that if you want to get something from the class, you should also do the homework.
Yeah, of course, yeah. Yes.
And we're not going to grade it. So it's up to you. You will see the solutions.
Oh, okay. So I would like some feedback on the homework, from the TAs.
You can go and talk to the TAs. I mean, it's open.
Okay. So I should just let my department know.
Yeah, let them know. Some departments actually want me to sign a form for auditing.
Oh.
Some don't care, so I don't know what your department wants.
Okay, I will ask them and email you.
Yeah.
Okay, awesome. Thank you so much.
Sure.
I have a question. I actually don't have a policy question, but so I'm a first-year master's student, and I have an idea for a thesis, and I guess I was curious what the procedure was to sort of get advising for that, or.
First of all, wait a week or two.
Right. Yeah, that's
because
true. That's very.
too many questions that are more immediate.
Right.
Send email and
Okay.
to me or to other people that you might be interested in, and we can talk.
Okay. Yeah, specifically, I'm interested in NLP, so.
Yeah.
I guess.
So in principle, I'm happy to talk about this, but I think probably not now.
No,
Yeah.
there's a lot of
Take a week
great.
and come back with the questions.
Okay, awesome. Great. Thanks.
Hi.
Hi.
My name is Brandon.
Hi.
I'm Shannon. Yeah.
So we're both bioengineering PhD students.
but there's a new program from the Penn Institute of Computational Science called, what's the name of the
Like
program?
a certificate?
Oh, you're in the same boat?
Yeah.
So you
Okay.
can come here. So we're talking about the same thing.
Advanced Scientific Computing. Yeah. And so when I say new, I think at least they started accepting students like a week ago.
Okay.
So, I mean, they already confirmed me, I don't know about you guys, but, essentially, taking a machine learning course is a requirement for the certificate. And I talked to the director of the program, and he said that he expects that should, in theory, change our priority on the list. But then, my question is, if our priority changed within the past week, how would we go about, like, what should we do, essentially?
So you know your priority now?
I don't. I talked to the director of the PICS program, and he said that he talked to some people, and it was his understanding that we should move up in the priority list.
Yeah.
But
So,
that being said, I mean, I have no.
so all
control
of you
over
are
this.
on the waiting list?
Yeah.
And do you see your priority when you look at?
Right now we're 5.
So we're.
Oh,
I
you
mean,
know
yeah,
that
yeah,
you're
yeah.
five,
Well,
okay.
at least we were 5 when we signed up because we're just PhD
So
students.
why don't we do this? I mean, I actually have no control of the priorities. I have control of the list, but the priorities is set by some program that was written in the academic office.
Okay.
Do 2 things. One is send me email so I know about this. 2, either send email or even better, go and talk to Nick. I can't remember his last name. He's in 308 ±1 in this building. If you don't find him, I can tell you in the email. He is responsible on the waiting list, and if he got a request from someone to change the rules for priorities, I mean, if someone got a request, he would be the one.
Okay.
So let's see, and next week you can update me if you hear that from me.
Okay. Cool. Thank you.
So, okay, same question. Okay, so just let me know, that you are in the same boat.
Sure.
If you all send me one email, that would be better. Just list your names,
Okay. Cool.
CC all of you, and so on. So it will save my inbox. So.
I completely understand that.
Okay.
Thank you.
Good.
Have a good one.
Yeah, you too.
Interesting. So a while ago, I was sending you the CGD, but then it's fine.
Yes.
So yeah. So here, thank you for sending it back.
Okay, you got it back, right?
Yeah, I got it back.
Oh, the signature thing.
It's a very
Okay.
different thing, and they didn't
Yeah.
accept that.
So I see that it doesn't print well. So here it is.
Thank you so much.
Okay.
All right. Thank you for bothering us all the
Sure.
time.
I'm a first year master's student in the robotics program.
Uh-huh.
So at this time, I'm not really sure in what direction I want to go in research or work. So the courses I've taken this semester are applied machine learning, introduction to robotics, and computer vision and computational photography. So I was wondering if these courses sit together well, or are they in entirely different directions, and whether they'll
No,
be
actually, I think
different.
they seem to be good. So computer vision, who's teaching computer vision?
Professor Jian Boshi.
Okay, yeah, definitely. He will also do a lot of machine learning in his class, but he will basically assume, I think, that you know some machine learning and focus just on some applications. Do you have an advisor as a master student?
Yes.
Who's the advisor?
Dr. Mark Kim.
Mark?
Mark Kim in the mechanical department.
Oh, for
main
mechanical,
department,
okay.
yes.
It seems good to me. You can also talk to your vision professor and see what they think. Who's teaching the robotics class?
Cynthia Sun.
Okay.
She's also
Also,
from
she also
mechanical.
have a mechanical, yeah. Yeah, I think it's good. I mean, I don't know what is your background. Do you have any background in